Good afternoon, everyone. I would like to welcome you on today's webinar. The theme is SCIA Engineer 19, What's New? My name is Jaroslav Broš, and I will present during this webinar together with my colleague Vladimír Příbramský. At the beginning, let's talk a bit about some housekeeping, how to using the GoToWebinar. By default, your microphone is muted. If you would like to ask or place some question, use the question box. And this webinar is recorded and will be published on our official SCIA YouTube channel. That have been all what's related to the housekeeping, and let's go to the content of the webinar and really what's new in a version of SCIA Engineer 19. Here is an overview and the grouping of themes related to the actual release. The tagline is Design Accelerated, and as you will show in the webinar, we will be speaking about the features related to the multi-story building, steel structures. We will have spent a couple of minutes related to the localization, interoperability, and at the end, we will be speaking about usability and speed. In the case of multi-story buildings, we can divide it into the several themes. The first one is analysis. We will be speaking about absences, property modifiers, and also Masonry Analysis. Then we will shift to the results, speaking about the integration member and some further enhancements of the 2D members. In the case of the design, we will be speaking about the concrete as well as about the composites. The other theme will be steel structures and localization. Under the steel structures, that's the brand new SLS check. Then in the case of the analysis, that's plastic hinges updates. And in the case of the localization, that's related to the Swiss code for steel and some minor improvements related to the open design in Brazil. Then some enhancements of Swiss concrete, Danish national annex, and certification of the common. In the case of the interoperability, we will be speaking about the Open API, XML2 enhancements, and also updates of our links to the Revit and Tekla. That was a short introduction, what you can see in today's webinar. And now I will give the word to the Vladimír, and he will go through the multi-story buildings and results.
So hello everyone from me as well. I'm Vladimír Příbramský, and I will show you parts related to theme multi-story buildings. As was indicated, is one of our main theme, not only for the version 19, but in this case it's the most significant one. First topic that I will be covering are the model modifiers, as they are called in this release. And model modifiers unify in under them both absences and property modifiers, in this case for load cases. I will get to details later. So the model modifiers were created as a unification of absences and property modifiers, and that was solely for the ease of use. So in the project data now there are no model absences, but this functionality is available for you through enabling it in the functionality tab. So reduction in the model types. Furthermore, the absences are now available in the post-processing environment default, which was in previous version the V17, and also they are available still as absences in the in the V16 and older. Current workflow with the model modifiers is in a way that multiple modifiers, such as absences or the property modifiers, are now stored in a group, and this group can be assigned to any load case when wanted. Important to note is that absences are now available by means of the model modifiers in the 64-bit version as well as in 32-bit version. So basically, it is migration of the functionality in the post-processing environment 16 and older into the default one. And also we included an improvement of drawing of results on absented members, which are now, in case of showing results, let's say 3D displacement on structure with both absented members and present members, these absented members are correctly displayed in the results. It is now possible also to create absence property for subregion, and it also works with the composites. Important thing is that these new absences or new implementation of them have similar limitation to the old possibility of calculating with absences, and they are now possible to be added on 1D members, 2D members and their subregions, and also on nodal supports. So in terms of property modifiers, which are now grouped with absences, those are earlier called property modifiers, and these property modifiers are available for load cases the same manner as absences. It is possible now to edit stiffness or mass ratio for 1D members and 2D members, and of course we are allowing to mix the property modifiers and absences in one modification group. These groups work for linear analysis, nonlinear analysis, and stability, and the restriction for the nonlinear analysis and stability is that in these combinations only load cases with the same group of model modifiers can be used, because that is quite reasonable to avoid having in the same nonlinear combination load case with some absences and other load case with different set of absences, which would make problematic analysis. Next topic that I am going to cover are improvements in Masonry analysis. For 19.0, we took the state what we had. Indeed, the Masonry material was available in the SCIA Engineer, but the workflow with it, in order to have correct and sane behavior, was quite troublesome. User had to apply experience and some tips and tricks in order to have the Masonry walls with reasonable behavior and not unrestricted connection to following concrete members. In 19.0, there is introduced a dedicated masonry wall to the elements with automatic reduction of arching effects, and also we have increased the nonlinear capabilities of edges or of contacts on edges of wall elements, which are now able to be set as well, in case of masonry, most useful is the nonlinearity behavior press only. So the main or the importance of the masonry elements is that they are easy to find and easy to use. In the tree, and if you select service structure under walls, you see right away the element named masonry wall. This element is available in the service once any material of type masonry is available or enabled in the project. The masonry wall is automatically orthotropic, and orthotropy is set in automatically based on the material and thickness of the wall in order to reduce the arching effect of the wall, which basically is possible to customize based on the user experience. For longer spans of walls, it might be prudent to use the arching, to include some amount of arching effect as is indicated by Eurocodes. So furthermore, masonry walls are available in both current or new projects. Masonry walls in current projects can be easily switched into the new behavior by just setting type of 2D members to be masonry orthotropic, and by that these walls get the flag which indicates bricks as it's shown on the image below, and so these members are clearly distinguishable between other types of slabs. Also, what is the main advantage is that this behavior with automatic orthotropy, reducing the arching effect, mitigates local singularities and mitigates favorable action between walls and concrete slabs or beams, because these beams are then loaded by, or beams supporting masonry elements are now directly transferring the load from them without the favorable shear effect of the masonry walls. To support the masonry elements, we also introduced the contact elements, which are linear parts on the edges of 2D members, which allows us now to introduce nonlinear functions on hinges on edges of 2D elements. In this case, the most commonly used is the press-only nonlinearity, and to compare some results, here we have the linear behavior and with compression-only hinges which are in compression, so that behavior is same in the linear or nonlinear analysis. If this hinge is in tension, well, in linear analysis this is connected. In nonlinear analysis there is clear disconnection between the supporting wall and the slab that is trying to deform upwards. So what are the use cases? To sum up this behavior is that the nonlinear hinges are available on 2D elements. I have here two sections from realistic projects to compare. We have isotropic with linear hinges and the masonry orthotropic types of elements with nonlinear hinges, and we clearly see that this usage together mitigates the both local singularities and, more importantly, tension in walls, which which basically is more clear to use when connected to concrete slabs. This was regarding analysis what I had prepared for you. Let me continue with results. And first improvement in post-processing environment default is enabling local extremes. Their usage is quite straightforward. It's same as in the old older post-processing environment, and it's mainly useful for continuous beams when multiple local extremes can be or are identified. We also enhance the sections on 2D members. Based on the feedback from our clients, from you, we get a lot of tickets that these sections are visible in the project, in the pictures all the time, and if they can be hidden. Sure, they can be now, because now they are now you are able to apply them under a layer, and this layer can be then hidden, or then they can be hidden by mere activity. And also we enable to calculate resultant value on section for clear use. Further enhancement of sections on 2D members is that currently we are able to have results on only single section and on single 2D element, which was not possible before. And clearly now, by selecting sections or number of sections and slabs, these results are drawn only on the selected items by the selected sections. Further improvement is by introducing a new entity, which is called integration member, which is very similar to integration strip, but is more advanced in a way that it allows you to integrate stresses into internal forces in a spatial diagram. It's useful very much for the multi-story buildings if you want to have one internal force for, let's say in this case was the core of multi-story building, which was composed by wall elements, or in more advanced you can use it for, let's say, bridges that are modeled solely out of 2D elements, yet the integration member allows us to see the in this case the bending moment in the same way as it would be a beam. So this is all from the design and results, and I hand over to Jarda again to present something about checks.
Thank you, Vladimir, that you told us a lot of information related to the analysis and the results. Once we are done with the analysis and we have seen the results, we may to start the design of concrete. And for that, we did several improvements and the developments. Here I have some summary related mainly to the design of 1D element. In version 19, we introduced so-called practical reinforcement auto design, which is the feature which converts the designed reinforcement into the practical bars, and these bars then can be used in the checks. Basically, that's the composition. We did something in the case of the shear reinforcement design, and we also do some improvements that the reinforcement is been compatible. We also did improvements in 2D concrete that in version 19 you are able to define your own reinforcement in 2D, and this reinforcement is then taken into account during the design of reinforcement. So you can easily use the templates for 2D reinforcement and the design. And moreover, what we also did is the export of designed reinforcement into the Alpan via the ISF file. We are planning to have the dedicated webinar just related to the concrete. It's named Automate concrete design in SCIA Engineer 19. It will be held on Thursday, 30th May, and our colleague Marwan will cover all the secrets behind these improvements in 1D as well as in 2D. So if you are really interested what's new, you definitely should go and visit this webinar. Once we have been speaking about the concrete, we could also speak a bit about the composite floors or composite design. What was enhanced or done in the case of the 19? We spent some times dedicated to the speed improvements, because we experienced that in the case of the large modules, sometimes it got stuck. So we improved the speed for large modules, and also if you had web openings, it was also a bit problematic. Currently, we improved the speed of the calculation. Once the calculation is done, you get some report. Here we also spent our capacity and the time to further improve the outputs which are coming from calculation. So we improve summary output. We add references into detailed output to easily track what's calculated and where you can find it in the Eurocode. We also add a system of error warning and notes, which can help you during your task which you have to accomplish during the design of composite floors. And what is also one of the, let's say, biggest enhancements in the 19, that's the auto design related to the secondary beams and also efficiency and web openings. And the same as in the case of the concrete design, there will be dedicated webinar related to composite. So stay tuned and register on the webinar, which is called Economical and Clearly Documented Steel and Composite Design in SCIA Engineer 19, held on Tuesday, 25 June. And our colleague Iveta will uncover the secret behind the composite and the steel. Once we are speaking about the steel structures, we did also some enhancement which we can mention during our webinar, and that's related to the serviceability limit state. That was the case in the version 19.1, in the version in the version 18.1. In the case of the version 19, we are able to check the deflections for the steel members. And what's also important, we did also some enhancement related to the calculation of and checking of the steel cambers. In the case of analysis, I mentioned the plastic hinges calculation. You have been used to in the previous versions that the plastic hinges analysis was related to the formal national standard and also the version of the pre-Eurocode standard. We updated this calculation to the latest version of Eurocode 3. We also added the national annex support, so for every country there could be the different coefficient which is used inside the calculation of the plastic hinges. And this calculation is available in the default post-processing environment as well as in a 64-bit version. Here you can see some, let's say, the typical steel frame, and you can see here the comparison for version 18.1 and version 19. Here that's the version of pre-Eurocode, and you can see that load on the frame is equal to 24.9, whereas in version 19 that's now that's the value of 26.2. That's because of the new way of calculation of plastic hinges and the different coefficients. So in that version, the design is more, let's say, economical than in the previous version. And if you can also notice, there is a significant change in the time order of the calculation. That was all what was related purely for multi-story buildings and various sub-themes like analysis or the design. Let me go to the completely different topic, which is called interoperability. Under the topic of interoperability, as usual, handling of different kinds of links or import-export, and also let me show you what we did for a bit specific tool, which we are calling XML tool, which is a tool which enable you to run SCIA Engineer from the command line or from the Excel. We do the enhancement which support engineering report. So you can define the SCIA Engineer project, some XML file which could be used as an update, and in the command line or in the process you can also create engineering report. If you have in the template various or engineering reports, you can select which one you would like to use for the documentation, and moreover you can also select and decide which type of export from engineering report you would like to use, if it will be just the DDS format or PDF, RTF. That's here what's supported. When we also speaks about interoperability and the connection to the third-party applications or things like MS Excel, we decided to came up with the idea to create open API. You may be asking why we did it. Let's imagine that we would like to create a complex frame and do the optimization. So have a look on this picture below, where you have really complex 3D frame. That's the real user project from the company Setec, who sent this project to the SCIA User Contest 2013. They create the complex shape and structure in the Rhino, and they export it to the SCIA Engineer to do the statistical analysis. We would like to offer our clients the possibility to enhance SCIA Engineer beyond its focus. It means extendability of SCIA Engineers with the various kinds of calculations, or if you would like to do some parametric study and you are using the Excel, you should be able to do it. we decided to unify several APIs from the past, and that the API should be really easy to use. If you are curious what's inside this topic Open API, just register into the dedicated webinar, which is called Parametric Design using the new Open API in SCIA Engineer. It will be held on 18th of June, and it will be presented myself. And here I will uncover the things on the background, and I will show you how to work with Open API in several languages. At the end, under the topic of interoperability, I would like to mention that in the case of SCIA Engineer 19, we update our links. The first one, it's Tekla link with the Tekla structures. Now it's compatible with the version 2018, 2018i, and the latest version 2019. Almost the same could be said also for Revit, where we are, in the case of the link, compatible with 2018, 2019, and version 20. Besides these upgrades, we did some small enhancement related to the stability and some other improvements reported by the users. The last topic which we will cover in this presentation during this webinar, that's the topic of the usability and the speed. Firstly, I would like to speak about the buckling and the buckling setting cache. You discovered during the usage of new buckling that you define your buckling in the case of the steel structures, and then you discover that you have to disconnect some nodes. So you run the disconnect, and then you lost all the settings related to the backlink. That's the past. It's in version 18.1. In version 19, we did an enhancement that you can choose that you would like to restore the backlink settings for the members once you do the connection and alignment once again after the changes of the construction. So once you define the backlink settings, it's cached, it's stored, nothing is lost, and then you can easily use it. Here it's the screenshot from the backlink settings that you can see that here for the member is set that it's cached as an BG1 Gelter group. Beside the backlink settings, I think you remember that at the beginning of 2018 and at the end of the 2018 and beginning of 2019, we run a survey and ask you on the list of enhancements for the version 19. Here is a map of the participants with the numbers. In a total, we have almost 800 participants thank you a lot that you participated and help us to improve SCIA Engineer 19. What was in the survey and what are the winners? Here it's the answer choices, and well, we committed to ourselves to deliver the top 3 items. Here is the list. You may guess who is the winner, and the winner is the engineering report, the better control of how tables are split across the tables. On the second place, that's the definition of combination, because sometimes it was a bit clumsy when I defined the combination. I have a long list of load cases. I choose one, but it didn't disappear from the list, so it was very, let's say, annoying if I had a lot of load cases. The improvement is that the selected load case is removed from the list of the load cases. On the third place, that's automatic connection of node and members. So imagine you model a structure and then run a calculation, and suddenly the dialog appears that the structure is unstable or it's singular because of not connected members. For the new projects which you are creating, there is set by default that before the calculation, there is a run of the connection of nodes and members. As you can see on the list, there are other topics. Today you heard about the improved visibility control of sections on 3D members, which was presented by my colleague Vladimir. So we spent also here some time on enhancement, and on the last row you can see the export of required design reinforcement into the ISF file that was mentioned by me during the quick introduction for the concrete enhancement for 2D, and more it will be shown during the presentation of Marwan on a dedicated webinar. What was also done, and it's selected or it's connected with the usability, it's the check of the singularity. It works for post-processing environments. There is no need of the separate run of the calculation in case of the instability shape, no other run of the solver. So it means that it's quicker, as you can see on the video, which is shown on the slide simultaneously as I'm speaking. It's a faster than the old solution that I mentioned, and there's also, let's say, successful detection of more instability shapes than in the previous version. So that's also the enhancement of the method of the detection where the problems could be. And now I would like to once again hand over the presentation to the Vladimir, and he will speak more about the other improvements related.
Okay, thank you for the presenter. A further improvement, which is basically a small renaming of the V17 post-processing environment, that might cause confusion because we are now in the version 19. So this type of the post-processing environment was renamed to default and will be from now on. And you can read more about this on web help. All the documents related to the post-processing environments were updated. Let me now continue with some technical improvements that I think would bring benefit to you all. And first one is with the OpenGL improvements. The OpenGL is a library using for rendering in SCIA Engineer, and we improved the rendering so that the rendered volumes are possible to view during the inputting of members. In that way, basically what you see is what you get is the approach. It is clear where newly added member intersect other members already in the model, and it should lead to less confusion. This is applicable to both 1D members, walls, or flat or any inclined slab, as is visible on these images. What it also allows you to do is you basically can utilize your graphical card to get first better and high fidelity rendering of volumes, and also speed improvement based on using the highest possible graphical settings available for SCIA Engineer. Here I have two comparisons of the load panels and how they are visible when selected. On the second picture, there are hidden members by the volume of translucent load panel, and these members are also rendered in a subtle way. Furthermore, this performance of GPU allows us to further see labels of both nodes or beams or whatever else is with labels enabled while changing the view by rotating or moving or zooming in the scene. The most important part of that we kept for one of the last ones are the speed up. The main theme of version 19.0 is design accelerated, and we took great effort in order to make SCIA Engineer faster in general and also specific areas that I'm going to cover in minutes to come. So for this general speed up improvement, I choose a project of quite extensive size, 2.5 gigabytes with lots of members. And first speed improvement in 19.0 is that projects are faster opened, and also, if it's necessary, when opening all the projects, the recalculation of the cross-section parameters are necessary, and this is speeded up by approximately 50 or up to 50%. And in cases of even older projects which might have corrupted references, the repair of these references is also much speeded up, but this is of course something that you don't use too often. More significant improvement is with the project saving, because here we implemented some parallelization in the process, and based on the size of the project, the time saved can be up to 90%, which basically makes in some cases viable to use autosave, because now if it takes only, let's say, 5 seconds instead of 1.5 minutes that it could take before, that is something that the autosave now is possible to use, and it does not slow down your workflow too much. And of course it works on normal save time as well. General speed up of manipulations in the 3D scene is basically linked to moving, copying, mirroring, or any other manipulations that you can do in the project, and these modifications are up to 50% faster than in version 18.0. Here in this case there is a significant amount of members, so here the speed up for this particular project was around 30%. Most important speed up that we present is the speed up of results and also analysis. The results on 2D elements such as checks or stresses, in this case those are stresses on 2D elements with extensive envelope combination, this got significantly improved by up to 80% of time. And also, the bigger the envelopes, the bigger are the envelope combinations, the bigger the impact. For this quite demanding project, some selection of some 2D members to be evaluated got in terms of evaluation of 2D stresses reduced from nearly 18 minutes in version 18 to mere 3 minutes 20 seconds in version 19. So in this case, the speed up is very significant. Further speed up is in Solver itself by clearer of temp data. We were able to present you with Solver that is approximately 20 to 60% faster than it used to be in version 18.0. And this was tested on 2 different projects, one with a vast amount of beams, around 40,000, and also on project with contrast, which was composed of 2D elements, slabs and walls. The bigger impact is with the usages of the 2D elements. Then there we get improvement about 60%, where for the beam analysis this is somewhat reduced, but further speed up is in the 64-bit version due to some code cleanup and clearer version. So there you can see that for 2D member analysis we got from 12 minutes or more than 12 minutes in version 18 to 4 minutes in version 19 in 64-bit version. Therefore, I can only recommend you all to use the 64-bit version whenever it is possible, and if you don't encounter any obstacles while using it. To summarize this, the speed up improvements in version 19, we have 2 types of optimization. First is the speed up of processes, as I just spoke about. We have the opening and saving time reduction. Then there is one important topic that I didn't show in the previous slides, and that is the regeneration of engineering report when opened with extensive amount of tables. This is significantly improved, like 95% reduction of time. We have a case here which got the regeneration time from 2 hours to 5 minutes. And furthermore, what I spoke of were faster results and analysis itself. The further is that we made some speed up small improvements for the workflow. Some modifications from viewing results, like you can view now results separately for in case of 3D results, for example, you can view and only calculate 1D members separately or 2D members separately or all together. Before that, all members were, or both 2D and 1D members were calculated, and then this was filtered. So this improvement in 19.0 deals with this issue. And general improvements we measured quite extensively on more than 10,000 of projects, and we in total, those projects were quite small, so most of these improvements that speed up, let's say, the results on 2D were not that impacted, but the impact still was noticeable, like 20%. And yeah, and that's that's all from this speed improvement, and I would like to hand over again back to Jaroslav to wrap up this session and make some conclusions. Thank you.
Okay, thank you, Vladimir. And before the wrap up, I would like to also inform you that in the case of version 19, there is also the change in the case of the protection. With the version SCIA Engineer 19, we are also releasing a new type of the protection, which is called the cloud protection. So beside the protection with the dongle or the floating system, you can also choose the cloud protection. How it works? It's simple. All SCIA Engineer users will be identified via their credentials. That means username, which is email, and the password. How the credentials will be inputted into the system, that's also very simple. That will be inputted during the installation of SCIA Engineer, or later on during the protection setup dialog, where you can select that you would like to use the cloud protection and which activation ID you would like to use for the login. User can manage his own license. That's done through the web page, or will be done through the web page, which is mentioned on a screen. Each license at the beginning will initially have one license administrator, and after the login, the administrator could add other users to invite the users to use the license of SCIA Engineer, or remove the users. For example, someone who left the company, then you can easily remove the access to the usage of SCIA Engineer via the cloud protection. If you are standard user, you just log into the system to view content of your license. What brings to you that's easier to manage the licenses? No more dongles. So there is no physical dongle. Everything is done in a cloud. It's no more conflict of drivers or the conflicts with the other softwares using the same kind of protection, and that means the less frustration for you. And that's also, let's say, suitable for the data centers, because it's easier to virtualize and once again remove the risk of the losing of the dongle. In version SCIA Engineer 19, you can choose if you would like to use the new system of protection, or stay on your standard old system of the protection, and that will change in the future, where there will be just the cloud system protection. And as my colleague indicated in his speech, we are reached the end of the webinar. We have been speaking about multi-storey buildings, where we covered the topics related to analysis, as model modifiers covering the absences, and property modifiers per load cases. We have been slightly touched the concrete design, where we are planning to have the dedicated webinar. The same was for composites, where I mentioned some speed improvements and retort enhancements. We have been speaking about steel structures and update related to the calculation of plastic hinges, the ability to do the check of serviceability limit state. In the case of the localization, we briefly mentioned our upgrades or updates of solution for the checks in Switzerland. In the case of the steel and concrete, we have been presenting at the beginning of the webinar the note related to the Danish national annex, and also some stuff related to the Brazil country. We have been speaking about interoperability, where I presented you the upgrades of Revit and Techlading, as well as briefly mentioned our new feature or new system related to the open API and enhancement of tool to handle the XML stuff-based calculation. And at the end, we have been speaking about usability, about improvements related in the backlink settings, check of the Singularity, about the customer survey. My colleague Vladimir have been speaking a lot about all the nice and well done speed improvements. And last but not the least, we have been speaking about the cloud protection, which is some kind also the usability topics, as you heard, that will remove some frustration points. Thank you that you attend our webinar. We have a couple of minutes which we will use for the handling of the questions which we have in our box. So thank you. We will remain online 2 minutes to finish the questions in the box. If it will happen that you will not get answered immediately, the answer will be sent on your mail after the end of the webinar. That was all from my side. I would like to wish you a nice rest of the day, and in the future, maybe in the other webinars. So bye-bye.
Thank you as well, and I hope you will like our new version that we present you. Thank you, and talk to you later on other webinar.